Okay, so we move on to question 10. And what does question 10 say? It reads the following. Cloud cycles make two-wheeled bicycles and three-wheeled tricycles. Last week, they made 14 cycles in total. If they use 38 wheels, how many cycles did they make? All right, so the question is, how many tricycles did they make? Did I say tricycles? Okay, so let X be the number of tricycles. This is a sign for number of tricycles that this group made. Okay, so they made 14 cycles in total. So the remaining cycles are bicycles. Okay. Now, you know that there are 38 wheels altogether. So each tricycle has got 3 wheels in it. Each bicycle has got 2 wheels in it. So altogether, the number of wheels is 3x. That's the contribution of the tricycles, plus 2 into 14 minus x. And this is the contribution of the bicycles. But we know that this is equal to 38. You are told that 38 wheels were used in total. So when you solve for x, you get 10. And that is the number of tricycles. So that's the answer. Okay, so x was chosen to be the number of tricycles. So let's just check this to see whether this is indeed the answer that I have advertised. Yes, it is true. The answer is 10. All right, so let's get on to the next problem, which is question 11. Now, question 11 reads the following. It says, 3 rectangles are placed as shown. So each of these are rectangles. If the outer perimeter of the L shape, okay, this is an L shape. The outer perimeter means if you go right round, that's the outer perimeter. That is given as 106 units. Okay, and to ask you, what is the area of this rectangle? All right, so the question is, what is the area of the rectangle? So let's the area of this rectangle is length times breadth, but we know that if this is 11, this is also 11. So we don't know what this is. So the area is 11x. All right. So the idea is to find x now. Okay. Now we do know that the perimeter is 106. Let's check the perimeter. So if we start here, from here to here is 15. With 11, 15, 17. And here it will be x. It's the same as the other one. And then it comes down here. And this is 17. And there's 11 here. And x here. So the perimeter is, to go right round, it's, if you want, you can see it's 15. Let's put 15 plus 11. I'll just follow the same path that I chose. And that comes back to x, and that is 106. So there it is. You have an equation involving x. There are 2 x's on this side. Let's say add up all these things here. Get 30, 41, 58, 75, 86. Add it quickly, and you see that x is equal to 10. Well, I don't know whether that's the correct answer. Oh, if x is 10, then the question is, what is area? That is the question, not x. It's 11 times 10, so it's 110. You must write down square units. They are not given. They just say 106 units. So you must say the area is so many square units. Okay, so that is the answer to that question. And just to check to see whether this is indeed the correct answer, we can go down here. There it is. In red, the area is given as 110 square units. Okay, now let's go on to question 12. This 12 has 6 factors. Okay, you can see 1, 2, 3, 4, 6, and 12. What is the largest 2-digit number with exactly 3 factors? Now, actually, we need to know something here. There's a way of calculating the number of factors. And I'm not going to go into detail with this, but you can read my book, 1000 Problems in Mathematics, Olympiad Problems, and the reason is given there. Or if you've attended any of the other classes, I'm sure you've come across it. But the number of factors of n, if you write n as a product of prime powers, let's call it p1 to the a1, p2 to the power of a2. If you factorize it, every number can be factorized as products of primes. And you put all the primes together to get p1 to the power of a1 and so on, then the number of factors is, you have to multiply several numbers, but the numbers are just one more than each index or each exponent. So it's a1 plus 1, you multiply a2 plus 1, go on and so on, multiply it, you get an plus 1, and this gives you the number of factors. So let's try it out on 12. And so, for example, you've got 12 is given. If you write down 12 as factorization is 4 times 3, and that's 2 squared times 3, and 2 and 3 are primes. Right, so you can write 12 as a product of prime powers, and therefore the number of factors, according to the formula, is 2 plus 1. Take that index, increase it by 1. Here the index is 1, so it's 1 plus 1, and that's 3 times 2, and that is 6. So you can see, oh, you have 12 by 6 factors. That is right. So you see it works here. So now if the number of factors is exactly 3, it means that all these numbers multiplied will give you 3. Now 3 is a prime number. So how can you do this? It means that all of these are 1, right? And only one of them is 3. That's the only way you can get product 3 factorized. All of these are 1, but if this is 1, then a1 is 0. So all these indices are 0 except 1. See? So n is equal to your original n if these indices are 0, then all this is 1, and there's only one prime, and there, that index, that an plus 1, let's say an plus 1, is equal to 3. So the an itself will be 2. So, okay, now you have to just go over that again, right? But the argument is that to get a product to be equal to 3, 3 is a prime number. So all of them are 1, so each of the indices are 0. So there's only one prime factor, right? All the others are 1. And you have that prime factor raised to an, but an plus 1 will be equal to 3. Okay, so the long and the short of the story is that the n is a square of a prime. What is the largest two-digit number, which has got 3 factors? It must be a square of a prime. All right, so you want to know what are the squares of primes. So n will have to be a square of a prime. And so what will it be? The primes are 2. N is equal to maybe 2 squared, or 3 squared, or 5 squared, or 7 squared, or 11 squared. And now it's going to be a 2-digit number. 11 squared is out because that's 121. And you want the largest one, so n must be 49. That's the largest square of a prime number. So it's quite a tricky problem, but once you know that n is a square of a prime number, then you have to look at the largest possible square of a prime number, which has 2 digits. Okay, so that takes care of that. We saw that n is equal to 49, and also there it is. So see how quickly I went to the answer here, but now the advantage of this class is explaining why the only numbers that have 3 factors are squares of prime numbers. And if you saw that for the first time, you wouldn't know why. Well, hopefully you understood that now. Okay, so let's get on to the next problem. Question 13 says here that the natural numbers are arranged in a regular pattern as shown. So you can see the pattern there. And how are they? You can see you're counting 1, 2, 3, 4, and then you go across here like this, 5, 6, 7, 8. You go across like that, 9, 10, 11, 12. And then you come down, 12, and then you go across 13 and so on. Now they want to know if the pattern is continued, what is the 100th number in column D? So you need to focus your attention on column D. It's column D. The first number is 4. Second is 6. Third is 12. Fourth is 14. Fifth is 20. Sixth is 22. All right. Now you'll see you've got 4, 6. That means you're adding 2, then you're adding 6. You're adding 2, you're adding 6. So there is a pattern, but it's not very clear. You're adding 2 different things at the same time. But if you're looking for the 100th number, it'll have an even position, because so the 100th number, this is the second one, fourth one, sixth one. So the 100th number is going to be the 50th number in the sequence 6, 14, 22. Now you can see you're adding 8 each time. Why 50th? Because you can see the row, the second row has got 60, the fourth row has got 14, and the sixth row has got 22. So it will have to be a number in the 100th row or the 50th row. All right. So you're jumping 2 rows at a time. Okay. And that'll come to 100. So you want to know what is the 100th number in this? So the answer is, okay, now, this is an arithmetic sequence. There's a common difference. The common difference is 8. And the reason for this, look, if you start here at 6, then let's count. 6, you got 1, 2, 7, 8, 3, 4, 5, 6, 7, and 8 numbers later, you come to this number, you come back to D. See, it's 14. So again, another 8, you come to 22. So you keep adding 8 to get to this. Now, you have to look at the theory on this. There's a whole section on arithmetic sequences. And the formula for the nth term. The nth term of a arithmetic sequence is A plus n minus 1 D. That's the formula where A is the first term and D is a common difference. So we're looking at, we know n is 50, you see. So therefore, the answer is, you put A is 6, it's the first term, and n is 50, so it's 50 minus 1 times D, which is 8. 49 times 8 is 392, plus 6 is 398. So the 100th term, 100th number is the 50th number, which we just calculated to be 398. So that's the answer. Okay, let's just check this to see whether it coincides with there it is in red. You can see 398. All right. So let's get on to the next problem. It is given here that the speeds of 3 athletes are in the ratio 3x 3 4 is 3 is to 4 is to 5. The corresponding times taken by these athletes to complete a race. So they give you the ratio of the speeds and they give you the ratio of the times, right? They don't tell you what the times are and they don't tell you what the speeds are. They will just give you ratios. And they ask you to calculate what x plus y is. Okay, so we have to use some okay, so here we're going to know exactly what they all travel the same distance. So let the distance, the athletes running the same race, let the, you see, but these three athletes to complete a race, let the distance covered by the athletes covered be, say, D for distance. I like using D for distance. Now, the speeds, we don't know what the speeds are, but the ratio is 3:4:5. So let the speeds be, let speeds be. Now you can't see three. Earlier on we said it's going to be 3 times something, 3A, 4A, and 5A. If the ratio is 3:4:5, the actual speeds will be 3A:4, A:5A. You can put any A you like. It'll always be 3:4:5, 3:4:5. So these are the actual speeds. Okay. So the units are not given. So let's just make this meters. And suppose these are seconds. No. Here it's meters per second. Speeds are meters per second. Now, they say that the times, so we can say let the times be, okay, you got 20x, 20y, so we can say 20a, we'll make it 20b. The ratio is given, bx, by. All right, so the actual times will be some number times 20, some number times, the same number times x. Right. Now, there is a connection between distance, speeds, and time. So we know that the speed times the time is equal to the distance. D is equal to speed times time. And this is the master formula in distance problems. So you've got, if you take the speed times time, so you got 60 AB equals, so you got that times that. That's it. They all travel the same distance. Is equal to 4ABX. Right? It's the speed and this is the time. And that's equal to 5ABY. Okay, the AB cancelled. So you have 60 is equal to 4x is equal to 5y. And if you get cancel the A's, now that tells you what x is. What x is? 60. So x must be 15, and y will have to be 12. 5y is equal to 60, so y must be equal to 12, and that gives you x plus y straight away. It's 27. So that's the answer. You're using the formula that the distance is equal to speed times time, and you're also exploiting the fact that they all travel the same distance. So in each of the cases, the speed times the time will be the same. And that's how you got this master formula here. And they're all equal to the distance. This is D. All right. So that's given to be the answer to the problem. The answer is 27. Let's just check to see whether this is indeed. There you see in red, you'll see it's 27. Oh, but I've got all kinds of complicated things there. And I've done it very much easier way. So this is, you see, each time I solve a problem, I solve it in different ways. And this looks rather messy. But the solution I gave is much easier. Okay, so let's just get on to the next problem, which is question 15. Question 15 says, 4 grandchildren live with their grandmother and the grandfather. The average age of all the 6 people is 30. Okay. So if you know the average is 30, then I'm going to write it down straight away. It means that the sum of the ages of the 6 people the average age is 30 of the 6 people. It has to be 6 times 30. You see, the average is the sum divided by the number. That's how you calculate average. You add up everything and divide by how many you have. So you've got that number divided by 6 is 30. So that sum must be 30 times 6. Okay, and you also have the average age of the 4 grandchildren. So the sum of the 4 grandchildren, I'm not writing it in full. Actually, we should say the sum of the ages of the 4 grandchildren is the average age is 12. So it's 4 times 12. So that's 48. So if you add the 4 people, you will one sum is 48. There are 4 people here. And then you're left with only the grandparents. And the whole thing is 180. And when you add the whole 6, you're going to get 180. So the extra is coming from the grandparents. So this will have to be 132. So the sum of the ages of the grandparents, the sum of the grandparents' ages is 132. Now they say the age of the grandfather is 6 years, the grandfather is 6 years older than the grandmother. How old is the grandfather? Okay, and an easy way of doing this is you got 2 numbers. If their ages were the same, it will be 66. But the ages are 6 years apart. So one will have to be 66 minus 3, and the other will have to be 66 plus 3. Um, oh, they are 6 years apart. Or 66 plus 3. Yeah, so the grandfather is older. So the answer is 69. This is the grandfather's age. If you don't understand where I got this thing from, I'm just half it and I look at either side. The one is 6 more than the other. The other way of doing it is, or you can say let grandfather's age be 6. Then the grandmother, the grandmother will be x minus 6. And the sum of these 2 ages, grandfather plus the grandmother, 6 years older, is, we know it's 132. We've just said that the sum of the grandparents' age is 132. So you got 2x is equal to 132 plus 6. Take the 6 to the other side, and you get 138. So 2x is 138, and therefore x is 69. And that's what I had. You see, I had here 66 plus 3, which is 69. And that's your grandfather's age. That's the answer to the problem. Okay. See, if you do the algebra, maybe it's much better to do it like this because you can understand it. But I like to take the midpoint in between and take on both sides. I just have to have it to get to see what's going on. All right, let's just check to see whether the same answer I have. Right, I got 69 in red. Okay, so that's great. I'm getting the same answers right throughout. So let's get on to the next problem. We now go on to question 16. All right, question 16 says, the diagram shows a large rectangle has been subdivided into three, oh, I see, two smaller rectangles on either side and a square in the middle. So the middle one is a square. Okay. And you got a rectangle here, you got a rectangle here. And they give you some distances. They say this is 8 and this is 10. It's not very clear. So this is 10 here. Okay, those are the only two distances given. And they ask you to find the perimeter of the larger rectangle. Okay. So there are quite a few things we don't know here. We don't know that, we don't know that, and we don't know these two. Right? But we know the middle is a square. So let's give a name to the side of the square. We call this A, side of the square. All the sides will be A. Right? And this will also be A here because these are all rectangles, so the opposite sides will have to be the same. So now we know this part here is A, and the whole thing from here to here is 8. So this little piece here will have to be 8 minus A. Because if you add these two, you're going to get 8. Likewise, this little piece here, the whole thing is 10, and this is A. So this is 10 minus A. All right. And we need this piece here also to get the perimeter. That's also 8 minus A. And this piece here you also need to get for the perimeter. Because I want to go right round. The second time, the same type of question is asked. So if you start here, let's start adding up all the distances. You got A plus, I'll add the whole 8 one time, plus 10 minus A. So I've got A, 8, 10 minus A. Come down here, another A here. Now add the whole thing here, it'll be 10. And then you got one more 8 minus A. So this is what we needed to find, the perimeter. But there's an unknown here, A. And we haven't calculated that A. But let's just see what happens here. With A minus A cancels. A minus A cancels here as well. So the A's disappear, and you got 8 plus 10 plus 8, which gives you 26. Right. So this is the perimeter. I just added it all around, and I get 26. So that answer came out very quickly. So let's just see whether this is indeed the answer. Oh, 36. So what happened there? Somewhere I got a wrong calculation. Maybe I didn't end at the starting point. Okay. Sorry. When you look at this, you can see you got. All right. You can try it, please. I'm not going to go back to this, but we got all the sides. As you can see here, it's the same thing. And we have to add up everything, and I made some calculation error. All right, so you can go and check to see where I went wrong. That will be your exercise. It's a simple calculation. Okay, let's go to question 17. Question 17 says, a dartboard consists of two circles, or you can see this dartboard. The shaded region is 2/5 the total area. So this part here is 2/5. That means the unshaded will be 3/5. So of the total area, this is 2/5 the total area, and this is 3/5. Now, if both dots hit the board, what is the probability as a percentage that one dot hits the shaded region and the other hits the non-shaded region? Right, now, this is a question on probability. Now, I think maybe the best way to do this is assume what assume what the area is. Just say, let the area be something. And I got 2/5. I'm going to make it so the 2/5 goes exactly into it. I'll make it 100. So therefore, the shaded area is 2/5 of 100. That's 40. And the unshaded is 60. Area is 100 square units. We don't really interested in that. Now, so what is the probability? Now, there are various possibilities. I'm throwing two dots. The two dots could be, let's call it dot 1 and dot 2. They both could be in the unshaded. Let's call it U and U. And they both could be in the shaded. First one is the unshaded. The second one is the shaded, first and second. Or you could have the first dot and the second dot. Could be the first one could have landed in the shaded and the second one in the unshaded. Or you could have had the first landing in the unshaded and the second landing in the shaded. All right. So for the first one to land in the shaded, or the unshaded, that is 3/5, 60 over 100. Really didn't need to put these numbers. It'll be 3/5. So 3/5 of the time, it hits the unshaded region. And for the second dot to also go into the unshaded region, it will have to be 3/5 times 3/5. It's 3/5 of 3/5, right? So that is the 9 over 25. All right. For the two shaded regions, they'll have to be 2/5. For the first dot to hit the shade region, the probability is 2/5 of the time. And for the second dot to hit this thing, also there, it has to be, the product will have to be the product of these two. So you've got 9 over 9/4. And here, 4 over 25 at least. So here, you can see it's going to be, shaded will be 3/5. The unshaded is 2/5. So that makes it 6 over 25. And here, it's the same, but you start off with 2/5. So the first dot is 2/5 and the second dot is 3/5. So if you add up all these, you get 9 and 4, 13, and 6 is 19, plus 6 is 25. There it is. So if you add up, the probability is 1. So that it means that your dot can be exactly in one of these 4 sections. So the question is now, what is the probability that one dot hits the shaded region? Doesn't tell you which one, right? And the other, it doesn't say whether it's the first dot or the second dot. And the second one hits the non-shaded region. So you have to take both these cases here, where the first dot hits the shaded and the first dot is unshaded. So it's going to be 6 over 25 plus 6 over 25. So these are the two where it hits the shaded and the unshaded. One of them hits the shaded and the other. So it's 12 over 25. So this is the probability. But so the probability that one of them is shaded, the other is unshaded, is 12 times out of 25. Okay. But they want it as a percentage. So this as a percentage is 12 over 25 times 100 over 1. That's how you convert to percentage. 25 goes into 100 4 times. So 4 times 12 is 48. And this is as a percentage, 48%. All right. So the answer to this question 17 is 48%. Let's hope this time I'm correct. Last time I was not correct. There it is. I didn't put it in red. So it's 48%. Okay. So let's get on to the next problem. It says here that an equilateral triangle has side 2 centimeters, side length 2 centimeters. What is the maximum number of points that can be placed inside and on the edges of the triangle such that no 2 points are closer than a half a centimeter? 0.5 is half a centimeter to one another. So you got the equilateral triangle has got side 2 centimeters. Let's just draw this equilateral triangle. Not bad. It looks like an equilateral triangle. Okay, the side is 2 centimeters. And you want to place points so that no 2 points are closer than 1.5. So suppose I start here. I'll put the first point here. So I cannot put the second point within half a centimeter, right? But I can put the second point on this dot here, exactly half. These 2 points, the distance is exactly half, and they're not closer. It's not less than half because they say closer than. So I can put the second point here, right? That's right at the extreme. And here too, I can put the third point here, and I can put the fourth point here. So all halves apart. And these 4 halves will give you 2. All right, so if you do this right throughout, you will see that you've got points like this. I'm going to divide and then down here, I got the 4 halves down here as well. Okay, and then you got these like that. Okay, so what you've got here now is, if by going across to all the other sides, then I have this point, this point. Now, no two of these points satisfy the condition. All right, so I've got, how many points have I got here? I've got 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's include this one here. So there are 15 points here. Now I've chosen, you have to think about why I've chosen these points like this. Like, this is like the critical points. Now there are lots of points which are exactly half unit from each other. So what happens is all these are now become equilateral triangles, because you've got all these lines are parallel. So original one was 60 degrees, 60 degrees, 60 degrees. So all these angles are 60 degrees. It's easy to see that. So you've got various equilateral triangles here. I think 1 plus 3, so 16 equilateral triangles with these 15 vertices. But now, if I take one more point, I'll have to put this one point inside one of these. I've taken care of all the vertices. There are 15 points. The 16th point, is inside one of the triangles. It has to be one of the triangles. All right. So now the question is now, and I'm going to suggest that that point doesn't satisfy this condition. It will be less than half from one of these chosen points. So let's see why that is the case. So let me magnify that triangle. And we know that the side of this is a half now. It's going to be inside one of these triangles. And this point is your 16th point. It's inside. Now I claim that its distance from one of these sides is going to be less than half. Okay. And how do we do that? You see, if I join this to these 3 points, you can see all 3 of them are obtuse angles. But it need not be like that. It could have been like that and like that. It could have been one acute and 2 obtuse. But you need to have at least one of them is obtuse. Right? You can't have all of them acute, all these angles, because otherwise the 3 angles will add up to less than 90 plus 90 plus 90, which is 270. But they add up to 360, you see. So one of them has to be obtuse. So if you take some of the angle is obtuse, in my figure I got all of them obtuse. Need not be, but so let's suppose now that so this angle here is obtuse. One very important thing is that the greatest angle is opposite the greatest longest side in a triangle. And this is an important fact. So we are going to use that fact. the largest angle in a triangle, any triangle, this is the largest side is opposite the largest angle, right? This is a well-known property of triangles. So therefore, this half is going to be the largest side in this triangle, which means that both these distances are going to be smaller than half. So you have that the distance between that point and two of those vertices are going to be less than half. So it doesn't satisfy this condition. So the maximum number that you can place for it to satisfy this condition is 15. At 15, I can make a situation where all of them, no 2 points are less than half. The moment I put the next one, then that condition is violated. You will have 2 points less than half. So this is the maximum number that can be placed. All right, it's a very sort of logical argument. I just want to write down what the answer is. See, 16th, 15 satisfies the condition. That means no 2 points are closer than half, but 16 does not. Right, so the maximum number of points that can be placed inside is 15. Beyond that, the condition is violated. All right. So let's just check to see if my answer is 15. They haven't said so, but 15 is maximum. All right. So it's exactly the same thing. All right.